Hello everyone and welcome back to our fourth video on aircraft observations and reports. You can make a pilot report of icing whether you have icing or not. It's always nice to know if there is no ice in the clouds, but likewise, if you are experiencing icing, it would be good to make a pilot report indicating that. To make a pilot report of icing, standard contractions are used to describe the intensity type, and then also if you are flying at a different altitude where you experienced the ice, then you can report that altitude, or if it was a range of altitudes. For example, if you're climbing or descending, then you can put in that range. Icing intensities are based on the rate of accumulation on the aircraft and also the effect on the aircraft. There are 4 different intensities. There's trace, light, moderate, and severe. The first rate of accumulation of icing that we'll talk about is trace ice. And there's the symbol for trace. It's just a simple U. And trace ice happens, or you can classify your icing that you're picking up as trace ice if it just starts to become perceptible on the aircraft. Where the rate of accumulation is greater than the rate of sublimation. The rate of sublimation is how fast it's disappearing. And you should start thinking about getting out of these icing conditions before they get worse. The FAA has updated their icing intensities in 2000 as a result of an NTSB recommendation, and now they include the rate of accumulation in inches per hour. So trace ice occurs when you are picking up 1/4 of an inch per hour on unprotected surfaces, such as the outer wing. The picture that I show here is probably one of the first places that you look for ice on older Pipers. They used to have a temperature probe sticking out the windshield, and if you're flying an airplane that is not protected for ice, this was one of the best places that you would look for trace ice. Light icing is where the rate of accumulation requires occasional cycling of manual de-icing systems, so you have to keep hitting the boots, and that hopefully minimizes the accretion of ice on the airframe. And you should start thinking about getting out of those icing conditions also. And according to the FAA, they believe that light ice occurs when you're picking up between 1/4 to 1 inch of ice per hour on unprotected surfaces. Moderate icing is where the rate of accumulation requires frequent cycling of your boots, of the manual de-icing systems, to keep icing at bay. And you should consider exiting the icing conditions as soon as possible. The rate of accumulation is between 1 to 3 inches per hour on unprotected surfaces. And then finally, severe icing is where the rate of accumulation is such that ice protection systems can't get rid of the accumulation of ice. You keep hitting the boots and it accumulates faster than you can get rid of it. With severe icing, ice accumulates in locations that are not normally prone to icing. So these are areas aft of the protected surfaces. When they mean protected surfaces, they mean de-icing boots or other types of de-ice. And also other areas identified by the manufacturer start to accumulate ice. Aircraft are not certified for flight into severe icing, so by regulations, if you get into severe icing, you need to get out immediately. The rate of accumulation is more than 3 inches per hour on unprotected surfaces. That's a lot of ice. If you're in severe icing for an hour, that means that you have more than 3 inches on the wing. Typically, if you start experiencing severe icing, you get out right away. There are 3 types of icing: Rime ice, Glaze, which is also known as clear ice, and mixed ice. Rime is kind of a milky, rough, opaque type of ice with lots of gaps in between it. Typically formed by droplets. As they strike the wing, they freeze almost instantaneously. That's a good picture of Rime. I've seen Rime that's a little bit more translucent than that, but that's a decent picture. Glaze, which is also clear ice. Most of the world uses the term glaze. Here in the United States, we use clear. But it's glossy, translucent iced, which results from very slow freezing of big drops with high liquid water contents. There's a picture of glaze ice or clear ice. And then finally, mixed is kind of in between. It's a combination of both. And that's what mixed ice looks like. When you report ice, you should report the intensity, the type, and also, of course, the altitude, but the air temperature, because it's really important that pilots know what the temperature is of ice. Here are some examples of icing. A lot of examples. The first one is around Wichita, and it is an urgent pilot report, kind of north of the Wichita VOR. Don't know the altitude, but it's a Boeing 717. And they say don't know what type of layer it is, but they're climbing through it. But it's at 2,000. The tops are at 72. It says moderate to severe mixed ice, and it said it quickly turn to heavy mixed icing. There's one up near Baudette. The next one, it's a PC-12. Probably know who's flying that one. Bases of the clouds, overcast 1,600 MSL, tops 35. Temperature is -5. Moderate mixed ice during climb. Next report is from Council Bluffs at 3,900 MSL. Citation reporting light Rime from 8,500 down to 3,900 during the descent. And around the Raleigh-Durham VOR, about southwest of the Raleigh-Durham VOR, at 8,000, a Cessna 208 Caravan is reporting a temperature -8 and severe Rime ice from 8,000 down to 4,000. The remarks indicate anything that doesn't really fit into any of the categories that we talked about already. So you can just about put anything in here. Specifically though, the FAA would like to know where there's wind shear or thunderstorms or lightning, sulfur dioxide gas, and that's a result of volcanic ash. So if you smell rotten eggs, then you're flying in a volcanic ash plume, and that's important to know. Also, if you see clouds on the horizon, you can report those or any other things. The Sky Spotter program is operated by AOPA. They have an online training program. You should take it and be a Sky Spotter. When you are a Sky Spotter, they'll put that at the end of in the remarks section at the end of the PIREP that you make. And then also at the end of the PIREP, they tell you who made the observation. They have a program where you can make observations online, and it's either done by dispatchers with airlines or with air traffic control facilities, in this case ATSC. So here in this example you can see FAA ZLA indicates Los Angeles Center, and it says that this observation came in from the web. So here's examples of lots of different types of pilot reports with remarks. And the first one is over Fort Collins, going from Cheyenne to Fort Collins, Wyoming, Cheyenne, Wyoming, Fort Collins, Colorado. It's a Piper Cherokee type airplane. Says it has haze tops at 7,000. Above that, the sky is clear. Visibility is 6 in haze, but above that, it's unlimited and there's no turbulence. The next one is over Alamosa, kind of to the east of Alamosa in Colorado, saying at flight level 390, 757-200 experienced light to moderate chop, and then light to moderate mountain wave, plus or minus 15 knots, reported by Denver Center. And then the third one over Findlay VOR in Ohio, an urgent pilot report at 500 feet. A Piper Meridian is reporting low level wind shear plus or minus 10 knots on final approach to runway 25, anywhere from 700 feet down to 500 feet during the descent. Here's a few other examples. BFI is in the Seattle area. It's Boeing Field. Reporting at 100 feet, a citation had low-level wind shear -8 knots during descent to runway 13 right. Next is Billings, between Great Falls and Billings, Montana, at flight level or at 12,000 feet. Beach 99 is reporting no turbulence, but generally good VFR conditions. And then over Alamosa, an urgent pilot report to the east, kind of northeast, about 43 miles northeast, at flight level 450, a Cessna citation reporting severe turbulence and mountain wave ±35 knots and ±500 feet, reported by Denver Center. And the next pilot report is 737 at 3,000 feet, reporting overcast skies, temperature of -5, moderate Rime ice at 3,000, and they're an IMC in tops at 4,000, but it's clear above, and that was reported by CAK Center. So with pilot reports, report any kind of weather that you experience. If you're not experiencing any weather, report that too, especially if it was forecasted there to be weather, like turbulence or icing or even clouds for that matter. Pass on the information if it's different. And then consider the type of aircraft that's making the pilot report. Severe turbulence reported by a Boeing 757 is different than severe turbulence reported by a Cessna 150. And then consider the time of the pilot report was made. Older pilot reports tend to get stale. Newer information is more timely. That's all I got for this video. And the next one, we'll look at AirReps.